Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, we are going to present our lab project report, which is library management system.
My name is Chin Jae-yao.
My name is Cho Teng Sian.
My name is Kausar Abdul.
My name is Hana Safia Husni binti Asro Husni.
My name is Tan Daulun.
Okay, so I'm going to present the introduction. So the first one is library management system is a software solution designed to automate and streamline the various operation and process involved in managing a library. It serves as a centralized platform for managing library resources, cataloging, circulation, user management, and other administrative tasks. It provides libraries with tools and functionalities to efficiently organize, track, and provide access to their collection. So the problem statement for this project is difficulty in managing large amounts of data, because if we use manual library system, managing large amount of data related to library, borrower information, and even logistics can be difficult and time consuming. The second is data errors, because entering data manually can lead to errors such as misspelled names, incorrect title, or incorrect authors, which can cause confusion and prevent wrong books from receiving the book they borrowed for. The third is poor library service, because without a centralized database system, it becomes time-consuming to retrieve borrower information or author's information, which can lead to long borrower service queues, unsatisfied borrowers, and a weak librarian service experience. The last is lack of real-time access, because manual library system do not provide access to real-time data, making it difficult to make real-time decisions related to borrow books, event logistics, or changes to pricing. So the objective for this project is to generate centralized data storage. A database system provides centralized data storage that is easily accessible and searchable, enabling easy tracking and management of huge data sets. Second is to increase accuracy and efficiency. A database system validates and ensures data accuracy, reducing errors, ensuring that borrowers receive correct information, and ensuring consistent and reliable access to library materials. The third is to provide equitable access to information and resources for all users, regardless of their physical location or circumstance. Next, to understand the needs and preference of their users and tailor their service accordingly. Next, to enhance library services, they can adopt library management system, digital repositories, discovery tools, and self-checkout system to automate and simplify routine tasks. The last is to develop real-time insight and control. A database system provides real-time data and insight into author, price, and publisher for quick analysis, decision, and adjustment. So the scope of the project is modules to be developed is the first one is registration module, which is to register as borrower. Next, borrower module to borrow books. Third, payment module to pay if borrower leads return. Fourth, book details module to set author, publisher. So the target users is borrower able to borrow books with accurate publisher and author. The second is librarian, able to update books details. So next, I pass to Darren.
So I will explain about the ERD. In this ERD, we have 6 tables, and between each tables, they have relationship. The first table is the publisher table. In this table, we have publisher ID as the primary key, and then we also have the publisher name, contact number, and address. And this table is related to books table. In the books table, we have book ID as primary key, and then publisher ID as foreign key. The foreign key references to the publisher table, And this means that the book is published by the publisher. And then we also have the title, general, price, quantity, and year of publish. And then the books table is also related to borrow table. In borrow table, we have borrow ID as primary key, and then book ID and ID as foreign key. So we also have borrow date, due date, return date, and fine. So this means that the book is borrowed by the person, and the borrow table is also related to borrower as well. In this borrower table, we store the information about the borrower, which is borrower ID as primary key, and then we have the name, status, phone number, and email. And then we have order book table. It is also related to books table. This means that the book is written by the author. So in this table, we have both attributes as primary key and foreign key, the order ID and book ID, and it is related to order table, which stores the information about every order. So we have the order ID as primary key, and then order name and date of birth. So next, I will pass to Hannah to explain about the business rules.
Okay, for the business rule, okay, for the first one, for publisher and book table, each publisher can publish one or many books. Each publisher is mandatory to publish one book, and each book is mandatory to have one publisher. And then for the second one, between table borrow and book, where each book can be borrowed by one or many. Each book is optional to be borrowed by zero or many, and zero or many borrows are optional to borrow books. And then for the third one, between book and author table, each book is written by many authors. Each book is mandatory to have one author book, and one author book is mandatory to have one book. Okay, for the fourth one, between table borrower and borrow, one borrower may borrow many times. Each borrower may borrow or not, and borrow is mandatory to have one borrower. And for the last one, which is between author and author book, each author can write many author books. Each author is mandatory to write one author book, and each author book is mandatory written by one author. Okay, and then for the data dictionary, there will be 6 tables, which the first one is table author. Here are the list attribute name with its detail, where for the first one, for the AID, which is represent author's ID, with data type char4, and it is a unique where it is primary key. And then for the A name, which is author's name, with data type varchar100, where it is a required data. And then for the DOB, which is the author's date of birth, with data type date with format month, day, and year. And then for the next one, for the author book, A_ID, which is the author's ID with data type char4. It is a unique data, and it is also primary key and foreign key in the same time, which refer to the table author. And then for the book ID, which is the book's ID with data type varchar10, it is a unique data with primary key and foreign key, which refer to table books. And then for the next table, which is table books, the first one is the book ID, which is the book's ID with data type varchar10. It is a unique data where it is also a primary key. And then we have title, which is the book title with data type varchar200, and it is a required data. And then for the genre, which is the book's genre with data type varchar30, it is also a required data. And then for the pub ID, which is the publisher ID, we set it to varchar10, and it is also a required data where it is foreign key which refer to table publisher. And then we have price RM, which is price of the book with data type number 52, and it is a required data. and quantity, which is quantity of book with data type integer, which is also a required data. And for the last one is year published, which is the year of the book being published with data type and also a required data. And then for the table borrower, for the borrower ID, it represents the borrower's ID with data type varchar 10. It is a unique data, which is it is a primary key. And then for name, which is the borrower's name with data type varchar 40, it is a required data. And then for the status, which is it determines the student or staff with data type varchar 10. We set it range student staff where it is a required data. We also set it default value to student. And then for the phone number, which is it represents the borrower's phone number with data type varchar 15 and it is a required data. And for the last one is email, where it represents the borrower's email with varchar 30 and also a required data. And then next, for the table borrow, the first one is borrow ID, which is the borrow ID for those who borrow the book. The data type is varchar 10 and it is a unique data, which is primary key. And then for the book ID, which is the book's ID varchar 10, it is a required data where it is also a foreign key that refer to table book. And then for the borrower ID, which is the borrower ID, the data type is varchar 10. It is a required data and it is also foreign key that refer to table borrower. And for the borrow date, which is the date of the book being borrowed, the data type date, where the format is month, day and year, and it is a required data. For the return date, date of the book should be returned, which is also the same data type date with the same format month, day and year, and also a required data. And then for the fine, which is the total borrower need to pay if the book is overdue from its return date, data type is number 52 and we set it default 0.00. And for the due date, which is the final date to return the book, we set the data type date where it is also a required data. And then for the last table, for table publisher, pub ID represent the publisher ID with data type varchar 10 and it is a unique data, which is the primary key. So for the pub name, which is the publisher name, we set it varchar 100 where it is a required data. And then pub contact number, which is the publisher contact number with data type varchar 100, and the last one is pub address, which is the publisher address with data type varchar 200. And then I pass to Darren for explanation about DDI.
I will explain about the DDL, which is used to create tables. So the first is the publisher table. We have 4 attributes and all of them are varchar 2. And I have to mention that the publisher ID is varchar 2 and we set to 10 characters because we will have many publisher and we'll have many different publisher ID. And the publisher name is required as well. And then the contact number and address can be null because we may not know their contact number and address. Next, we have books table. We have book ID as primary key. Same, we use the varchar 2 since we need the leading zeros. And we have title, general, publisher ID as foreign key, and price, quantity, year of publish. And next we have order. We have order ID. We set to character data type 4 characters as primary key. Because the order ID is fixed, we have 4 characters, and order name it is required, and then date of birth. And then we have order book table. So we have order table and then book ID. These two are both primary key and foreign key. And for the order ID, we references the order table, and book ID we references the books table. And then next we have borrower table, in which we stores the information about the borrower, in this case students. So the first is the borrower ID. We set it to primary key, and then we have name, status, phone number, and email. All of them are not nullable. And then we have table borrow. So we use the borrow ID as primary key here, and then we also use it as varchar to the data type, the same reason as in front. We'll have many borrow activities. And then we have book ID and ID. These are the foreign keys. For the book ID, we reference the books table, and ID we reference the borrower table. And then we have borrow date, return date, and fine is the amount of money they need to pay for overdue. Next, I will pass to Chin to explain about DML.
We use DML, which is data manipulate language, in order to insert, update, and also delete our data. So for example, the insert, which is insert publisher information into publisher table. We insert into publisher table value PUB publisher 069 Scholastic INC now. So the result will show PUB 069 Scholastic INC and now. For the second example, for insert, which is insert book information into books table, we insert into the books table value and the result show at the below. So for the update a publisher name of publisher PUB 069 to Pelangi. So we update the publisher table and set the publisher name to Pelangi, where the publisher ID equals to PUB 069. So after we execute the publisher PUB 069 and the publisher ID and the publisher name will update to Pelangi. So for the second example, update price and year of publication of book title Harry Potter in books table. So we update books, set price RN 39 ringgit 90 cent, and the year published 2002, where the title of the book is Harry Potter. So after we execute for the books Harry Potter, it updated to 39 ringgit 90 cent and year 2002. Next is for delete the data. In order to delete the table, the book title Harry Potter from the books table, we delete from the books table where the title Harry Potter. So after we execute, the book which is called Harry Potter will be deleted. In order to delete publisher PUB 069 from the publisher table, we delete from publisher where the publisher ID equals to PUB 069. For more DML details about our library system, you might visit to this webpage. Next, I'm going to pass to Kausa in order to explain the SQL and relational algebra.
So the SQL and the relational algebra. So the first question is list all books in the library. So the SQL is select star from books. So this is the relational algebra. So this is the results. For more result, you can click here the link to view more. So the second question is to display non-fiction book. So the SQL is select star from books, from table books where genre equals to non-fiction. So the relational algebra is alpha genre equals to non-fiction from table books. So this is the result. So you can view more the result in link here. So next question is list all book with price under 30 ringgit. the SQL is select star from books where price RM less than 30. So the rational algebra is alpha price less than 30 from books. So the result is like here. So for more result, you can click the link here. So I pass to Jayao.
Now I'm going to explain question 4 to question 6. For question 4, list all the books that have been borrowed in June. For the SQL, select the book title as book title from the books table, join to borrow table on book ID equals to borrow book ID, where the borrow date bigger or equals to date, the first day of June, and borrow date smaller or equals to the last date of June. So the result will show at the bottom. For more result, might click to the link. For question number 5, which is list the student who borrow, including the borrow date and the title of book. So select the borrower name as student name and borrow date, book title as book title. From the borrower, join to the table borrow on borrower ID equals to borrow ID. Join to the table books on borrow book ID equals to book ID. So the result shows at the bottom, and click the link to view more result. For question number 6, which is list the total books borrowed by each student. So the SQL, select the borrower name as student name, count the book ID. From borrower, join to borrow on borrow ID equals to borrower ID, group by borrower name. Result show at the bottom. So now I'm passed to Tingxian in order to explain the other SQL.
And so now I will explain the SQL from 7 until 9. So the first one is list all the book publishers. The SQL is select distinct pub ID, pub name, pub content, no pub address from publisher. And below is relational algebra. And next is the result. And for the more result, you may click into the link. The next question is list the number of books according to each publisher. So the SQL is select pub ID, count book ID as node of books. So we rename the book ID as node of books, and from books table group by pub ID. The next is relational algebra, and the result, for the more result, you also can click into the link. For next query is list the student who has been fined because of debt overdue. So the SQL is select ID, and we rename fine as fine RM. From borrow table, where fine is exclude 0.00, and below is the relational algebra and the results. Now I will pass the other SQL and RA to Hannah.
Okay, for question 10, which is find the book that has the same author. Okay, for the SQL, select A.AID, which is the author ID, B.title, A.author's name. From author A, you will join to the author book where we label it as AB on author ID from author and author book. And then you join back to table books B on book ID, where from table author book equals to table book order by author ID in ascending order. So this is the relational algebra, and it will display the result for title of the book with the same author name. And then you can click the link below for more result. And then for the next question, which is question 11, list the books published in specific year. Okay, for this one, there are two ways to do the SQL. The first one is by using the year published. Where we use the SQL is select star from books where year published equals to XXXX, which is the year that you want. So as example, select star from books where year published equals to 2017. The other way that we can do is by organized according year. So the SQL will be select b.publisher_id, c.title, b.year published. From publisher P, it will join table books B on b.publisher_id equals to p.publisher_id, order by year published. So this is the relational algebra, and for the result for the year published, it will display the specific year that you want. So as we want just now is 2017, so it will display all of the books that we published in 2017. And then for the next one, when we organize according the year, it will display all the year but in ascending order. So it will display from 1992 until the latest year. So you can click the link below to look for more results. And then for question 12, list all the books according to each genre. So the SQL will be select star from books and we will order by genre. This is the relational algebra, and the result will display all of the book where it will organize according to each genre, starting from fiction until the last genre. So you can click the link below for more results. Then I'll pass to Darren for the next SQL.
So I will explain the SQL from question 13 to 16. For question 13, we list all book categories that library has. In this case, I use select listing because we only want to know which genre we have in the library. We don't want the genres to repeating. And you can see at the results, we only have 4 genres: fiction, non-fiction, personal finance, and language. Next, we list all the books that are published by the same publisher. In this case, we have 2 options. First, by using publisher ID, and second, we use publisher name. By using publisher ID, we select all information from the books table and we put the condition publisher ID equals to PUB XXX. As an example, PUB 001. And by using publisher name, we select the book ID, title, genre, price, quantity, year of publish, and publisher ID and name. So in this case, we use the join. We use information from books table and publisher, and we put the condition, the publisher name like. So as an example, publisher name like Willie, and in the results you can see that all the books shown are published by John Willis and Son, and then the results for publisher ID as well, they are all under PUB 001. And then for question 15, we list all authors who have more than one book written by him or her in the library. So we rename the table. We rename the order book table as A1 and then order table as A2. So we display the order ID and name, and then we put the condition having count order ID more than one means that the order ID appears more than once. So in the results you can see these are the authors that have written more than one books and the book is in the library. And lastly, we list the information of the student who borrowed the books under personal finance general, including the book they borrow. So in this case, we use information from 3 tables: borrow, borrower, and books. We display the borrow ID, name ID, book ID, and title. And we put the condition where general equals to personal finance. And then so you can, in the results, you can see that we display the borrow information and the student's information and informations about the book of under the category personal finance. Next, I will pass to Teng Xian to explain about the conclusion.
Okay, now I will explain about the conclusion part in our project. So database play an important role in the effective functioning of library management system because database ensure that library institutions stay up to date. Database also offer a reliable and efficient means of storing vast amount of library-related information electronically, so libraries can systematically manage and access their resources, adapt to technological advancements, and meet the evolving needs of their patrons. One of the key advantages of employing a database in a library management system is its ability to accommodate a wide range of data types. As we know, libraries deal with diverse types of information, including books, journals, multimedia resources, user record, and more. So a well-designed database can handle these diverse data sets with ease, ensuring that each type of information is accurately stored, managed, and retrieved. Through careful database design and implementations, libraries can establish efficient structures for categorizing and organizing their collections, enhancing the overall efficiencies and usability of the library. Furthermore, database offer unparalleled flexibility, allowing for efficient updates and modifications. With a robust database management system, DBMS, like Oracle Apex, library can swiftly adapt their catalog and information system to ensure that the most current and relevant data is available to library users. This flexibility not only improves the overall user experience but also enhances the library ability to remain relevant in the digital landscape by providing accurate and up-to-date information to its patrons. Throughout this project, the utilization of database has been a significant learning journey. The initial step was to identify the entities and their relationships, which helped in designing an appropriate relational database schema and entity relationship diagram (EID). The database was created and tables were constructed to store the relevant data, ensuring data integrity and following normalization principles. Challenges were encountered during the development phase, such as optimizing query performance, handling large data sets, and ensuring data consistency. So to address these challenges, our group conducted extensive testing and implementation to identify errors in query execution and optimize the manipulation of large amounts of data. So in conclusion, database play an indispensable role in the efficient management of library resources and services in today's digital era. They form the backbone of library management systems, providing a structured and reliable repository for information. So we believe that database play an important role as library cornerstone to remain libraries as essential pillars for education, research, and community engagement in the digital age. So that's all from our group. Thank you for watching.